So today we're going to talk about solving quadratics. Okay, we haven't solved quadratics before. We've written equations for quadratics, but we haven't solved them yet. Okay, we did solve a little bit of them last chapter when we were talking about polynomials. Today we're really going to focus on quadratics. Okay, now we're going to spend quite a few days solving quadratics because there's 5 ways I need you to teach you to solve quadratics. 5 seems excessive, right? Except when it's given to you in a whole bunch of different ways, you need to be able to know those ways to be able to solve them, right? Okay, so we're spending a lot of time on solving quadratics, not because it's hard, but because there's lots of different ways for us to learn. Okay, the first way we're going to learn is to solve by graphing. Okay, so I'm going to give you these 2 graphs. I want you to write them into your notes, please. I can zoom in a little bit, make it a little bit easier to see. Does that help? Okay, so far? You got them drawn?
Yeah, big time.
So if we're solving by graphing, like what are we doing? Yeah, we're graphing it, but how does that help us solve?
Where it passes through.
Like what do you mean? Can you be more specific for me? So I need to see where it crosses. See where it crosses what? What'd you say? Just the x-axis, right? Where it crosses the x-axis is going to be the solutions. So the way I solve by graphing is by looking with my eyeballs, right? Okay? So in this first graph, where are the solutions? So where are they? God bless you. God bless you. -2 and 1. So x equals -2 and 1. Done. What about on the right graph? X equals 2 and what? 5, because why? Huh. Done. Are they always that easy? No. In fact, there's a time where solving by graphing is not the greatest plan. When is solving by graphing the greatest plan? When it's crossing at -2, when it's crossing at 1, when it's crossing at 2, when it's crossing at 5. When it's very clear where it's crossing, right? When it's kind of in the middle of everything, ooh, I can use my calculator to find out where those are by finding the zeros, right? But there's probably better ways to figure out the solutions than graphing. But specifically talking about graphing, we're seeing it where it crosses the x-axis, and the best time to do that is when it crosses at a nice place. Okay? So you're going to choose to solve by graphing, first of all, when it tells you to solve by graphing, right? And then second of all, if it's nice.
So is this.
Square roots. Square root is the next way we're going to talk about solving quadratics, is by square roots. Okay? So here's 3 sample problems that we're going to do together. X squared equals 49. X squared minus 4 equals 21. And the quantity x plus 3 squared equals 7. Okay? So let's start talking about the first problem. X squared equals 49. Now, I think that if I know you guys as well as I think I do, you think that you could tell me the answer right now.
7.
And you think it's 7, right? And I would have to take points off. It's not that it's not 7. It's that, what's the fundamental theorem of algebra? Do you remember that when we talked about it when we were polynomials? What's the highest exponent? 2. So how many solutions am I supposed to get? 2. And you told me the answer was 7. Is that 2? Is that 2 solutions?
No.
So I need you to think about this for a second. We're going to think about it and then we're going to do it mathematically. Is that fair? What 2 numbers multiply together to equal 49? I totally agree with 7 being that. 7 times 7 is 49. What is the other number times itself that gives you 49? Good guess. Nope, good guess.
I don't know what equals 49. Oh, that add together?
Multiply. Multiply. What times itself equals 49? I agree that 7 does.
What's half of 4?
What else times itself equals 49? What about
It has to be like...
negative 7? Right? Okay? So here's how we're going to show that mathematically. You ready? How do you undo a squared?
Square root.
We square root it. Oh, look, there's the words. Okay? Square root, square root. Who put the square root sign in the problem?
Me.
Us. We did, right? If we put the square root sign in the problem, we have to remember to write plus or minus. We put the square root sign in the problem, we have to remember to put the plus or minus on our answer. Okay? Now you know it's a quadratic, so you know you got to get 2 answers. Wait, are we always going to get 2 answers?
Yes. Well,
Can we go up here and look at this graph right here? We got 2 answers here and 2 answers here. So I kind of lulled you into a false sense of security, right? Okay? Could we have 1 answer? How could this graph show that I only had 1 answer?
If the vertex is on...
Absolutely. Absolutely. If the vertex is the only thing that's touching the x-axis, I'm only going to have 1 solution. Yes? Could I have 3 solutions?
No. It's not. It doesn't.
Parabolas go down and then they come back up. Or they go up and then they come back down. They don't turn.
Yeah.
That's polynomials. That's something else, right? So can this ever cross the x-axis 3 times?
No.
So I only have the option of 2 or 1.
Good.
Or
No. None.
or none.
None.
Right? None. How could it be none?
Because it's not on anything, it's floating.
Right, so, okay, floating, okay? So it's if it's all the way above the axis or all the way below the axis, right? So floating, that's fine. We can say floating, that's fine. That's fine. It makes sense in your head, right? So that works. Okay? But for these, how many answers am I going to get? Most of the time we're going to get 2 answers, aren't we? Okay? All right, so look at this problem. How are we going to do this problem?
You're going to subtract.
Add 4 to both sides. If I add 4 to both sides, what do I end up with?
X equals 25.
X squared equals 25. How do I undo a squared? Square root. Square root. Who put the root sign in the problem? So what I have to remember?
X equals plus or minus.
Plus or minus 5. We good?
Are these like all the different types of ways?
Nope. This is just, I'm just showing you 3 ways today. We'll get some more ways.
The second way?
We're on the second way. We did graphing first, now we're on square roots. Can we go back to this problem real quick? Because I forgot to do something. That was my fault. Is plus or minus 7 the right answer?
Yeah.
Is there a way we could be absolutely positive of that?
Yes.
How?
Plug it in.
Plug it in. 7 squared.
49?
Does 49 equal 49? Okay. Negative 7 squared.
49.
Does 49 equal 49?
Yeah, because negative times negative.
So I know for sure that that answer is correct, right? So go to this one that we just finished. 5 squared.
45.
25 minus 4. 21. Does 21 equal 21? So I know 5 is correct. Negative 5 squared? So negative 5 times negative 5. 25 minus 4. Does 21 equal 21?
Yes.
So again, I know without a shadow of a doubt that those answers are right, don't I? Okay? And the reason I could square root right here was because why? The thing being squared was isolated, right? We've got to isolate our squared term. So look at this example then. How am I going to do this one? See, that's what people have wanted to do today. They've wanted to distribute, but here's the thing. Wouldn't distributing make it more difficult?
Yes.
It would, because here's the deal. Isn't this a squared term? It doesn't look exactly like this, but isn't this thing right here being squared just like this thing? So couldn't I take the square root of it? Yes, I can. Okay? I can square root both sides, just like that. Just like I did before. Because remember what I said, what you need to do is isolate the thing being squared. Isn't this thing being squared all by itself? There's nothing being added or subtracted or multiplied or divided to the thing being squared. I know there's stuff going on inside. I'm not asking that. I'm asking, is the thing being squared isolated?
Yes.
If the thing being squared is isolated, then I can take the square root. What do I get when I take the square root of something being squared? Yeah, I just get that something, right? What do I get on the right-hand side? Who put the plus or minus sign in? Who put the square root sign in there?
So we put the plus or
So we put the plus or minus. Do you know the square root of 7?
Nope.
Neither do I. So leave it.
Oh.
You and I both know that there's times for us to put numbers in the calculator and get rounded answers. Do I want rounded answers today, or do I want exact answers?
Exact.
Exact. Okay.
Exact.
Am I done?
No, we have one more.
What do I have to do?
The 3.
I have to subtract the 3. Please, 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 do not subtract the 3 from the 7. The 7 is on the inside of the root. I can't get inside of the root unless I'm taking the root. I'm just going to leave it negative 3 plus or minus root 7. And that's the answer. That's the exact answer. Now, could I check this? I could, and I should, right? Negative 3 plus the square root of 7 plus 3. Well, what happens with negative 3 and positive 3? That's 0, right? So all I'm left with is the square root of 7. What's the square root of 7 squared? 7. Does 7 equal 7? Yes. What about negative 3 minus the square root of 7 plus 3? What happens with the negative 3 and the positive 3? 0, right? So I'm left with the negative square root of 7. What's the negative square root of 7 squared? 7. Does 7 equal 7? Yeah, then I know that those two answers are correct. Does that make sense? Okay, one more. One more way. Factoring. My second favorite F word.
What's number 1?
French fries? What are you guys thinking?
Wait, what?
French fries is my first favorite F word.
Profanity?
Oh my goodness. Ridiculous. We worked really hard on factoring last chapter, didn't we? Yes? So, how am I going to factor this problem right here then?
You're gonna find. You're gonna wait. No, you can do it by grouping because you can do 2 times 24.
First, I have to GCF. You're on the right track. You're on the right track. But first, I have to find GCF, right? Is there a GCF in this problem? 2. Now, you know how before we just had to factor it out and kind of drag it along with us? We don't have to do that anymore. What I can do is divide both sides by 2. Because before we were just trying to we were factoring an expression, right? Now we're trying to solve. That means I need to get rid of that 2, not just take it out. Okay? So when I factor out a 2, what am I left with when I factor 2 out of each one of these terms?
X squared plus 7x plus 12 equals 0 over 2.
Equals, and what is 0 over 2?
0.
0.
Whoa.
Now, how do you want to go about solving this?
The x multiplies to what and then times.
So AC?
Yeah.
So what's AC in this problem? 12. And what's B in this problem?
7.
So what two numbers multiply to be 12 and add to be 7?
3 and 4.
And because my leading coefficient is 1, can't I go straight to my factors?
Yeah.
So x, what'd you say?
Yes.
X plus
3 and 4.
3 and x plus 4?
Yes.
Now here's the thing that we have to do next. if I multiply, isn't this a number right here? One number and one number? If I multiply two numbers together and my answer is 0, what has to be true about at least one of these numbers? How can you get a 0 when you're multiplying?
The x has to be 0.
One of them has to be 0. Do you know which one it is? I don't.
Sounds like a belief clue.
So I have to think about if both of them are.
Oh.
So I'm going to take each factor and set it equal to 0 and solve it. On this one, I subtract 3 from both sides, and I get x equals -3. And on this one, I subtract 4 from both sides, and I get x equals -4.
Whoa.
Am I right? You cannot assume I'm right just because I'm the teacher. I'm a human, and I mess up sometimes. I already proved that, didn't I? Okay? All right, -3 squared. 9 times 2, 18. 14 times -3.
14 times -3.
So -42. And then plus 24. What's 18 minus 42 plus 24? It is. It's 0. Does 0 equal 0? Then I know that that is a correct answer. What's -4 squared? 16 times 2? 32. 14 times -4? -56 plus 24. That's 32 minus 56 plus 24. It is. Does 0 equal 0?
No.
Then I know that that is my correct answer. The second correct answer. Does that make sense?
Yes. Correct.
Okay, one more?
No.
One more example. Let's do this one. You know what people have tried to do today on this problem right here? Square root.
That's bad.
You know why? Because there's an x squared right here. And that's what we did up here, right? We just square rooted.
Well, that's square root, not factoring.
Correct, because there's this term right here. If this term was not here, could I solve this with square roots?
Yes.
Yes, but because there's a term right here, I cannot square root either side. Okay, because this side for sure doesn't have a square root. Okay, so what am I going to do here first?
Subtract it.
You're on the right track, but not x.
1. No.
20.
20.
Why am I going to subtract 20 from both sides? I need it all equal to 0. Absolutely. So if I subtract 20 from both sides, I get x squared minus x minus 20 equals 0. Is this something you know how to factor?
Yes.
Okay, what's AC?
-20.
-20. And what's B?
-1.
-1. What two numbers multiply to be -20 and add to be -1?
5 and 4.
What kind of 5 and 4?
-5, +4.
-5, +4. And because my leading coefficient is 1, can't I go straight to my factors? Once I have my factors, what do I do with each factor? Perfect. X minus 5 equals 0. X plus 4 equals 0. Then I just solve each individual equation, right? Add 5 to both sides. X equals 5. Subtract 4 from both sides. X equals -4. Do they both work?
Yes. Plug it in.
5 squared
25.
minus 5.
20.
Does 20 equal 20?
Yes.
Then I know that this one is correct. -4 squared.
16.
16 minus a -4.
It's going to be
Remember, minus a negative means plus. So 16 plus 4? 20. Does 20 equal 20? So guess what? Is that correct?
Good question. Since we know for sure that the first one works, wouldn't we know for sure that the second one
We never ever want to assume. Okay? It's a good question, but we never want to assume. Okay? Any questions about graphing, square roots, or factoring? Do you think you can solve quadratics using graphing, square roots, and factoring? All right, Marcus, I go.